Okay, so theorem. Okay, so let's let f of theta be equal to a times tangent of n theta plus c, and then on the outside plus d, or, let me move that a bit closer, or f of theta is equal to a cotangent of the quantity n theta plus c, and on the outside plus d. So then, number one, the amplitude, which is the vertical stretch, is going to be the absolute value of A. Number two, the period. Remember, the period for tangent and cotangent was half that of the other four. So the period P is going to be pi divided by the absolute value of n. Number three, the phase shift. Once again, phi is going to be negative c over n. And last but not least, and that's n is an absolute value, and the vertical translation, vertical shift, I'll just call it shift, is d. Okay, so for example, plot the following functions. So plot the following functions. So number one, let's plot f of theta is equal to tangent of the quantity. Let's do 3 theta minus pi over 4 plus 1. Okay, so first I'll rewrite f of theta is tangent of the quantity 3 theta minus pi over 4 plus 1. But now I'm going to factor out the coefficient of theta. So this will be 3 times the quantity, theta minus pi over 12, and then plus 1 on the outside. So the amplitude here is still 1, so that's a coefficient. The period, remember period for tangent and cotangent is simply pi. So that's going to be pi over the coefficient, 3. The horizontal translation, or the phase shift, is counterintuitive, so that's going to be to the right by over 12 units. And last but not least, the vertical translation is going to be up 1. Okay, so let's see what we can do here. So theta versus f of theta coordinate axes. And actually, let me move that line down 1. So theta, f of theta, we have 1, 2, 3, 4 quadrants. 1, 2, 3, almost 4. Amplitude is 1, 1, 2. Okay, so this would be actually 2 quadrants is the normal period for tangent, but of course we're dividing that by the coefficient 3. So all the normal quadrants, of course, will be divided by 3. So nothing changes there. So this corresponds to negative pi over 6, negative 2 pi over 6, or pi over 3, negative pi over 2, and, oh shoot, guess it doesn't go all the way, negative 2 pi over 3. Okay, so this is interesting because notice that pi over 12 isn't a quadrant, but do you agree that it's half of pi over 6? So it's actually half a quadrant. So so this would be pi over 12, is halfway to pi over 6. So it's actually a shift right of half a quadrant. Okay, so normally tangent is 0 at 0, and every 2 quadrants is 0. And normally tangent would go uphill in reading direction, like so. However, we need to shift tangent horizontally so we can place his vertical asymptotes. So the horizontal shift is actually half a quadrant to the right. So that means that everything, the vertical, let's see, so -2. So my vertical asymptotes will actually also be shifting half a quadrant to the right. Remember, vertical asymptotes are not affected by vertical translations. So all these asymptotes are shifted half a quadrant to the right. Once again, half a quadrant to the right. Okay, so now the graph of tangent would look something like so, with an amplitude of 2. Had I done that first, I probably should have. So half a quadrant to the right, amplitude of 2. Half a quadrant to the right, amplitude of 2. Half a quadrant to the right, amplitude of 2. But finally, what do I need to do with this? I need to shift everything up. Actually, I really don't like the way that looks, but I guess I have no choice at this point. Okay, so finally I'm shifting everything up 1 unit. So everything now goes up 1 unit from where it was. So finally we'll get something that looks like so. Up 1 unit, up 1 unit. Where is my -2? Up 1 unit. Everything gets shifted up 1 unit, up 1 unit, up 1 unit. Okay. Yes, once again, it looks pretty bad, but hopefully you understand the process while watching what I'm doing. Okay, let's just do one more example. I think that'll suffice for these. So example, or actually that would be subscript 2. So subscript 2. Let's plot f of theta is equal to, without a change in amplitude, let's just do cotangent of 4 theta plus pi over 2 minus 2. Okay, so f of theta, which is cotangent of the quantity 4 theta plus pi over 2, from which I'm subtracting 2. Let's factor out the coefficient of theta. So this becomes cotangent of the quantity 4, open parentheses, theta plus pi over 8, from which I'm subtracting 2. Okay, so my amplitude, of course, is just 1. My period for tangent and cotangent is pi divided by the coefficient of theta, 4. My phase shift, phi, that is my horizontal translation, counterintuitive, so that's left, negative pi over 8. And my vertical translation, up, down, will be down 2. Okay. So theta versus f of theta coordinate axes. So theta and f of theta. So we have 1, 2, 3, 4, and 1, 2, 3, 4. I know that for tangent and cotangent, 2 quadrants is a full period, so that would be pi, but I'd need to divide that by the coefficient 4. And remember, this is equivalent to just taking each of our quadrants, pi over 2, pi, 3 pi over 2, and 2 pi, and dividing them by the coefficient 4. So let's just do that. Okay, so going backwards, that'll be negative pi over 8. That's interesting. Negative pi over 4, negative 3 pi over 8, and negative pi over 2. So notice that my horizontal translation is to the left. Pi over 8, that is 1 quadrant in this instance. So amplitude is normally 1. We'll keep it that way. And I know that cotangent usually has an asymptote at 0 and goes downhill in reading direction, and then has an asymptote every 2 quadrants. So normally cotangent would go downhill in reading direction with an asymptote being the y-axis, but not with the horizontal translation. So first, this is just normal cotangent. Okay, so shifting horizontally, left 1 quadrant. So everything gets shifted left 1 quadrant. So all my zeros and my asymptotes. So the asymptotes that were on the y-axis are now shifted to the left 1 quadrant. So everything's shifted to the left 1 quadrant. So that is where cotangent used to go through 0, is now an asymptote. And vice versa. That is, wherever there used to be an asymptote, cotangent is now 0. Okay. So we know cotangent goes downhill in reading direction. Okay, so that's 1 shade darker for the second movement. And now the final translation is going to be down 2 units. So I'm going to take each of these points and go down 2 units. So let me mark that here. So this y-intercept is now down here at -2. This y-intercept is down at -2. And all of my y-intercepts are down at -2. But otherwise, the graph still looks pretty much the same. Trying to draw this. It's not easy to draw it well, for me at least. Something like this. Okay, so yes, of course, once again, it doesn't look very nice. I don't know, maybe we can make this one a bit better. Okay, something like that. Okay, hopefully this is making sense. Now, you don't have to draw all of the guiding lines. I'm just doing it to show you what I've done here in order to plot this. It does help. And then you can kind of lightly erase it. Okay. That concludes section 4.3.